Hello and welcome to our brief introduction to quantum physics. Quantum mechanics is a fascinating field that has revolutionized our understanding of the world around us, from the smallest subatomic particles to the largest structures in the universe. In this 10-minute script, we'll explore some of the key concepts and discoveries of quantum physics. Act 1: The building blocks of matter. Let's start at the very beginning, the building blocks of matter. Everything around us, from the air we breathe to the screen you're reading this on, is made up of atoms. Atoms themselves are made up of three types of particles: protons, neutrons, and electrons. But it wasn't until the early 20th century that physicists began to realize that the behavior of these particles defied classical physics. In 1900, Max Planck proposed that energy could only be absorbed or emitted in discrete packets, called quanta. And in 1905, Albert Einstein proposed that light could also be thought of as made up of quanta, which he called photons. These discoveries paved the way for quantum mechanics, which describes the behavior of particles on a subatomic level. Act 2: The uncertainty principle. One of the most famous concepts in quantum mechanics is the uncertainty principle. Proposed by Werner Heisenberg in 1927, the uncertainty principle states that it's impossible to measure both the position and momentum of a particle with absolute precision. The more precisely you measure one, the less precisely you can measure the other. This might seem counterintuitive, but it has been borne out by countless experiments. In fact, it's the reason that electrons are often depicted as clouds of probability rather than as discrete particles. Act 3: Superposition and entanglement. Another key concept in quantum mechanics is superposition. This refers to the idea that particles can exist in multiple states simultaneously. For example, an electron can be in two different energy states at the same time. Entanglement is another strange phenomenon in quantum mechanics. When two particles are entangled, measuring the state of one particle instantly determines the state of the other particle, no matter how far apart they are. This has led to the possibility of quantum computing, which could potentially solve certain problems much faster than classical computers. Act 4: The many worlds interpretation. Finally, let's touch on the many worlds interpretation. This idea remains controversial, but it highlights the strange and counterintuitive nature of quantum mechanics. Closing. And that's just the tip of the iceberg when it comes to quantum physics. From the behavior of particles to the structure of the universe itself, quantum mechanics has profound implications for our understanding of the world around us. We hope this brief introduction has piqued your interest and encouraged you to learn more about this fascinating field. Thanks for listening.